Good afternoon and welcome everyone. It's nice to see such a well-filled room to hear about the report from a closed workshop that we've had with a room full of heavyweights for the first part of this day. My name is Maria Leptin. I have the great honor of being the president of the European Research Council. And it's the ERC that has organized the workshop today, and it's on behalf of this workshop that we want to report to you the results from this workshop. Why are we here? The topic was innovation for Europe's competitiveness, and the stimulus from the workshop really comes from informal discussions we've been having over the last 2 years, where often the idea about stimulating innovation and competitiveness of Europe comes with the idea that we should shove more money into that step of innovation that leads to competitiveness. And I've also had many conversations with industry, the pharmaceutical industry, the chemical industry, etc., where the CEOs of big companies are very well aware that that's not where the problem lies and that's not where the money needs to go, but they rely on the research, the blue sky discovery research that is funded by taxpayers' money that serves their industries in an essential way. So we thought we'd just bring these people together, the scientists who do that kind of research, the policymakers and politicians who need to decide what to do with taxpayers' money, and the industry who know what they need. And so those are the people we've had in this workshop, representatives of leading high-tech industries, quantum, telecommunication, chips, AI, etc., and researchers from a range of fields, and you will see some of them on the stage here. We also had two of our commissioners, Executive Vice President Virkkunen and Commissioner Zaharieva, with us for part of the afternoon, and we had a number of members of parliament, one of whom we'll hear now. So we will actually now hear from as the first speaker, we'll hear from Lina Galvez. I'll say something about her. Then we will hear from one of the scientists who participated, Ben Feringa, and then we will have Robbert Dijkgraaf summarize the output of the workshop, and then we'll have a discussion on the contents of the workshop. That will really be the core. That will be the juice of today. We will also write up the workshop, the contents, and we'll make it available to anybody who wants. So talk to any members of ERC staff, leave them your cards if you want to be sent the report from this workshop, which we hope we can manage to get together in a reasonable amount of time. So our first reporter, our first speaker from the workshop will be Lina Galvez. She's Spanish. She is a member of the European Parliament. She is also, and very importantly, a professor for the history of economic institutions. So really an important background knowledge she has at Sevilla. And also here in Brussels, she has highly relevant and important functions. She's a member of the ITRE committee, the Innovation, Technology and Research Committee, former vice president of that committee, I believe, and she's a huge supporter of fundamental research, so we're very pleased to have her here. And also she's chairs of the committee that deals with women's rights and equal opportunities. So, Lina, please come up here and give us your take on today's workshop.
So thank you, Maria, and thank you to the European Research Council, obviously, for all the work you do, but most especially for this workshop, because it has been very inspiring, I think very important, especially in the current moment. So thank you to all of you that you have participated, because it has been really good. I'm really looking forward to these conclusions. So what was clear from it, and it is also clear for our side, at least for the ones that champion good investment in research and innovation from the European Parliament, it is that we really need to concentrate on research and innovation in order to boost competitiveness. So it has to be the core of our competitiveness and our competitive strategy. Obviously, for that, we need to have in mind the broader picture, not only externally, that we are listening every day what is happening in the world, how many things are changing, but also internally, because it was clear also from this morning discussion how much we need to deep our single market, to end up our single market, but obviously that will mean more Europe, and more Europe in many other sense, also in a more political sense, probably in a kind of a fiscal, or at least a proto-fiscal sense. So this is one of the first key message I would like to give, is that we need more Europe. Even for being competitive, for this competitiveness, we need more euros. And then we need, obviously, this research and innovation to be the core of this competitiveness, and for that we need a better governance, synergies among the different programs, and also to improve our research and innovation ecosystem. We were talking a lot on policy for science, but I insisted as well, and as a member of STOA, there's Marcus here, the panel of the future of science and technology at the European Parliament, we need also science for policy. We need more inputs for science in order to take the better decisions for the whole of the society. And possibly we need also a better science for the society in order to not to teach, but to really to make people also to think in a more scientific world, or at least to better support science. For that, we need possibly a more scientific education and better communication, including risk-taking. That was something we were talking about also a lot. And for that, we need specifically to fight against stereotypes, with make us probably more risk adverse that we really needed, and that is especially goes for women. We are we grow up less confident in ourselves, and we need really to break up this stereotype. That brings me to the second point I want really to make clear. I have a clock there, which is talent. I always like to say that talents are equally spread, but opportunities are not. So we really make that opportunities for everyone and all over Europe. I think the global package we have as Europeans is matched. We have excellent science, excellent scientists, we have the talent, and we have a society based on fundamental rights and democracy. And we have the resources. We were saying we really need to make it better, to use it in a better way. So for that also, instead of following the direction that is following now the United States going against, for instance, gender equality or diversity, we need to keep with our fundamental rights. And when we back this Choose Europe that is in Manuel Aitor report, that it is very good, we also need to think on our own researchers, not only on attracting very good researchers from abroad, but also to work with our own researchers. And I finished with that, and also to challenge and to have a most positive vision of science, because now disinformation, anti-science, and conspiracy theories are at the core of anti-democratic movements. For that, we really need to make science in the core of our democracies, and that will make us definitely more competitive, but as well to retain and to maintain our fundamental values and our democracies. And for that, We need the support not only of the parliaments of the member states or the different government, industry, business, association, but also the society. After that, we circle back to the importance of both science communication. And since after me will be Ben Feringa to be the next speaker, I remember our conversation last night about how important it is really to communicate, to better communication of science to the society. So really looking forward to hear what you say, and thank you very much. Thanks a lot.
Thank you, Lina, especially for emphasizing the importance of these fundamental values that we must protect here. We see how fast they can be lost, how shockingly fast they can be lost. Okay, so our next speaker is Ben Feringa. He will not summarize from the workshop. He will do what he does in an amazing way, namely inspire us. You get an introduction, just wait a moment. So, Ben won the Nobel Prize in Chemistry in 2016 for molecular machines. And those of you who wonder what molecular machines are, they are not machines made out of molecules, but they're molecules that are machines. He'll hopefully say something about that. Ben was also a former member of the Scientific Council of the ERC, and we have another Scientific Council member here today who came specifically for this event, Sylvie Lorente. So he was a former council member, and he was a 10-year grantee of the ERC. So a really successful repeat grantee of the ERC. He's very closely involved with industry. We'll probably hear about that as well. And he is a passionate advocate and supporter, advocate for and supporter of youth and talent. And you can see how he does the inspiration. I'm sure he'll give us a small sliver of that. Ben, it's a great pleasure having you here.
Thank you very much. It's a great pleasure and a great honor here to briefly speak here at this ERC event. We had a tremendous day, discussions, going far beyond our current horizon, ladies and gentlemen, is an adventure towards our future, which will bring challenges for our young talents in Europe, realize dreams for our people, and provide ample opportunities for society and industry. It was mentioned, I'm a professor of chemistry and molecular nanoscience at the University of Groningen in the Netherlands, and you will not be surprised that I include a little bit about the art of building small. Synthetic chemists like myself build molecules and materials in the laboratories, being the basic discoveries for modern industry and society, for all the products, your smartphone, your car, the airplane, novel pharmaceuticals, energy carriers, alternatives for our current plastics. But scientists do not work in isolation. These advances that shape modern society are only possible with a solid basis in fundamental science and cooperation among many disciplines: chemistry, physics, material science, biology, computer science, etc., and of course together with our partners from industry. In my team, we also invent molecular motors and machines, indeed, tiny machines, 1 billion of a meter in size, 1 million times smaller than what I show here. Why? Curiosity-driven research, which brings motion and lifelike functions to inert materials. Supported by ERC grants, purely based on scientific excellence and creative ideas, allowed me to work for longer periods to perform research in completely uncharted territory. We often take inspiration from Mother Nature, and we build through fundamental science a basis for future industrial innovations. Wasn't it Leonardo da Vinci, more than 500 years ago, already noted, where nature is finishing producing its own species, man starts, with the help of Mother Nature, to build an infinity of species. Yes, indeed, building our sustainable society of the future, we will have to establish a scientific basis, making discoveries and go far between nature, and our universities play a key role in that endeavor. But we also should make clear to society, and it was just mentioned before, and to the general public, why science is so crucial: knowledge, insights, and facts. If we ask the question, how to shape our future, there is not a simple answer. But let me discuss a small perspective from education and research. Myself teaching chemistry at the university and performing research, we are constantly confronted with the question, what are the major challenges? How to proceed forward? What focus should we take to the future? We all know predicting the future is difficult, so let me emphasize, as a scientist, the best way to predict the future is to invent it. That's what we try to do together with the support of Europe. Let's not forget, ladies, I'm sure you all have an iPhone, eh? Let's not forget that this iPhone, introduced only 17 years ago, completely changed our world. The way we now communicate and share information. I almost daily experience that young people can hardly imagine there was a world before the smartphone. But let's not forget that the fundamental discoveries were made in the late 40s and early 50s of the past century. The physics with the transistors and the chemists with the liquid crystal displays. And nobody would have predicted we would have 50 years later a smartphone. The word did not exist. No one would have predicted that. And remember, John Goodenough and his colleagues did the major fundamental discovery of the lithium-ion battery in the 70s, which not only brought him the Nobel Prize in 2019, but also made it possible that we can now build electric cars and that we can power the smartphone. Fundamental discoveries, and similar fundamental discoveries are currently happening in information technology, molecular nanoscience, robotics, sustainable catalysis for chemical process, energy carriers, novel biomedical technologies, and I can all go on and on and on. Starting points for real breakthroughs for a greener, healthier, and less energy-demanding society, and shaping the European industry of the future. Focusing on science and education, ladies and gentlemen, invest in basic science, enable our young scientists to experience the joy of discovery. Allow the young talents in Europe, indeed, to look far beyond our current horizon. Give them freedom to explore, acquire knowledge, but in particular stimulate their creativity and imagination. Wasn't it Albert Einstein who noted many years ago, knowledge is limited, imagination encircles the world. It's a key message I want to convey to you today. Scientific breakthroughs, real innovation, and building a sustainable society for the future indeed starts at the bottom. It needs creativity and imagination. Education, excellent basic research, the training of young scientists, expose them to international cooperation and confront them with the fundamental challenges of science. In this context, I cannot emphasize enough how crucial the European Research Council, the ERC, granting scheme have been for Europe. It's arguably one of the best initiatives ever taken in Europe. And I was recently in the United States, and they are really jealous. And that's a good sign. Together with the proof of concept grants, the European Innovation Council, EIC programs focusing on startups and industrial innovation, it will lay the foundation for the European Union of the future. More than ever, knowledge will be power. It allows us to solve many of the problems facing society and provide opportunities for joint global development to a better world. And bringing knowledge to practice, we should realize that in the decades ahead, knowledge will be economic power. Maintaining and building the sustainable manufacturing industry in Europe, this is at stake. Taking the lead in the world. Currently, there are tremendous opportunities. Knowledge will enable us how to distinguish in the flood of information that comes to us every day, which information is really important and what should we neglect. Building knowledge means that we have enabled our students to achieve training at the international frontiers of science. And in my field of natural science, over 90% of our graduates go to industry. It's not sufficient to give them training for today or tomorrow. We need to allow them to look far beyond our current horizon, as they will be the real innovators in society and industry in 10, 20 years from now. Let's not forget that. I'm a scientist working on molecular nanotechnology indeed, building motors and machines 1 millionth of a meter in size. Often I get the question, why do we need these tiny machines? The same question was asked to the Wright brothers slightly over 100 years ago. Why does mankind need to fly? If God wanted us to fly, he would have given us wings. Realize we built a Boeing and an Airbus in Europe. It's not a pigeon. We admire the pigeon, but we can build an Airbus that can carry 400 people across the ocean, 1,000 kilometers an hour. Try that with a pigeon. But also we should be modest, because my friends in biology tell we cannot build a pigeon. We cannot build a single cell of the pigeon, not one of the machineries in the cell of the pigeon. This is where science stands. Why should we build these tiny motors and machines? This is very fundamental science, but it has great promise. Realize all the products, as I mentioned before, in daily life are static. But your body is full of tiny machines. The fact that I can lift my arm, that I can talk to you, that I can see you, all these machines in your body. There are billions of these tiny machines that make it possible that we can walk and talk. Building these small machines will build us artificial motion to all kinds of things. Numerous smart materials for biomedical application, artificial muscles, self-healing, self-cleaning materials. We have now the first windows that clean themselves. In the future, you don't have to clean your car anymore. And maybe more important, when you have a scratch, it will repair itself. I recently had a scratch in my finger. If you keep it clean, it repairs itself. If I make a scratch here, it doesn't repair itself, and the same in your car. But in the future, 20 years from now, we will have it. Smart drugs, soft robotics, recycling of plastics, a lot of fundamental challenges that are depending on responsive functions. And they will make it possible that we get the materials in the industry of the future and realize the tiny robots in your body, I don't know if you realize that, all these nano robots, the billions of robots in your body, they recycle half of your body weight every 24 hours, every day. Can you imagine? What is one of the biggest problems we are facing in Europe and the world? Recycling our materials. We are simply not smart enough. Your body recycles through these tiny machines, half your body weight every day. I don't eat half my body weight. It's all recycled. We are hearing a lot about the next industrial revolution. Do not forget, scientists all over the world work now on this new energy storage systems, new technologies, genetic revolution, etc., new medicines. Difficult to say which innovations will come first, but one thing is certain. Based on this fundamental science, it will change our society and industry tremendously. Imagine the future. We have to leave our comfort zone, ladies and gentlemen, if we really look forward to our sustainable society. Major investments in fundamental science stimulate our young students, and on top of that, cooperate between academia and industry to enable the real breakthroughs in 20, 30 years from now. Creating excellent research environments, indeed, and allow leading scientists to work for a longer period, at the most challenging questions. It made it possible for me to realize my dreams. I worked with people from 13 different countries, with young talents, and it was through the ERC granting schemes that it was possible that I could work for a couple of decades, indeed, on these very demanding fundamental problems, and it paved the way to Stockholm. The European Horizon programs facilitate, indeed, cooperation across borders, and I cannot emphasize enough their importance for our future. There is quite some political discussion these days about borders. Science and education, ladies and gentlemen, has no borders. Strong cooperation will bring us forward, both among academics, between countries, and between academics and industry. Remind the words of Louis Pasteur. Science knows no country because knowledge belongs to humanity and is the torch that illuminates the world. Let's together keep this torch burning. And for years now, I have experienced this strong cooperation with our industrial partners, with scientists, etc. Based on the experience I just mentioned in the past decades, I'm convinced there are tremendous opportunities, especially at these times, for Europe. Invest in science, invest in cooperation, and make it possible that we can invent our future. It will not be sufficient to do more of the same. We deeply have to think about our research culture, making ample space for the young talents, create a major playground at the bottom to discover, And industry and society should be thinking how much they want to invest really in science and in our future. Perhaps it's urgent to be a bit more daring, a little bit more risk-taking. If we really want to invent our future and come up with entire novel possibilities, ladies and gentlemen, I cannot emphasize enough, the real innovation starts at the bottom. I strongly advocate, as you can conclude from my message, to invest in our young talents. Give them the opportunity to work on demanding questions, freedom to discover, and let them benefit from international training and expertise. And to conclude, continue to build strong international programs and bring experts together. There where science is probably the most powerful at the basis, and we have experienced that through the ERC programs. We face a wake-up call for sustainability and collective knowledge, and that will make the difference. And my tiny machines? Science or science fiction? You perhaps will remember this 20, 30 years from now, when we hope for realized self-healing materials, smart windows that can clean themselves, I mentioned it already, and in the more distant future, the surgeon will inject a nanorobot in your body to detect a defect cell or bring a medicine exactly where it's needed to treat a tumor. From frontier research to future innovations. Looking at science, there are indeed great opportunities, and we are part of a joint family with a common mission to make discoveries, maintaining the excellence of knowledge and quality of thought. And our most important duty, once again, I cannot emphasize it enough, to train our young students and give them space to explore the next generation that will shape our countries. Let me finish to emphasize human imagination and creativity is really sustainable in this world. Thank you very much.
Thank you, Ben. Talk about scientists, full-blooded at heart. This was it. Great. I will, after this, hand over to Robbert Dijkgraaf. Robbert is a physicist. He's also from the Netherlands. He's had a distinguished career in physics, which ended up with him over the last decade or so being the president of the Institute of Advanced Studies at Princeton. He's come back a couple of years ago to become Minister for Research in the Netherlands, and you know what happened to the government in the Netherlands, so unfortunately we no longer have him there in that function. He's now taken on, or will take on, the presidency of the International Science Council. I should say Robbert is also a passionate and gifted communicator, writer, and media personality. So he really is a broad talent, and he will now give the summary of the outputs of the workshop, and he will then chair and moderate the panel. So, Robbert, thank you for being here, and we look forward to your summary.
Yeah. Thank you, Maria, and also giving me the impossible task to summarize a discussion, a full day of discussion that was so dense with so many smart remarks that it's basically impossible to condense. I will make an effort, and then we'll bring out some of the highlights, I hope, in the panel discussion. I think we all agreed that there are no great challenges, whether it's climate or energy or health or digital, where research and innovation will not play a crucial role. It's absolutely essential for our society, for our innovative, competitive economy, and for science itself. And we do this, in a time when we see vastly accelerating technology, somehow in a new renaissance, but we also see a background of geopolitical tensions, isolist trends. So it's like the world is stepping both on the accelerator and the brake at the same time, which is kind of dizzying. But it was a very optimistic day, because I think we all agree that science research is the only really reliable source of optimism. We can always do things better. So let me briefly mention a few of the themes where our discussion circled around. So one was scale. The observation that, if you look at productivity gains It's often in those companies, these research efforts, where work at scale, and that one of the things that we have to fight, so to say, is fragmentation. That there are many challenges yet in the European Union to really complete the single market, to remove internal barriers. We will talk about it. And that we have some wonderful examples in Europe. The large-scale infrastructures, think of our European institutions and projects like CERN and EMBO or Airbus, or we'll talk about it too, AI, where the whole can be more than the sum of the parts. And this was also discussed about our policies. There's also a fragmentation of policy where we can really bring things more together. A second theme was, I would say, the architecture of the research enterprise. And often when we talk about regulation, again, regulation, you have good and bad regulation. You can have smart and dumb. And it was observed that often, we have good regulation, but then it's in the implementation, the 27 implementations, where a lot of the issues are being emerge. And that good regulation should be enabling, should not be hindering. And it's also part of the narrative. We should not, somebody said, shouldn't always complain. We should see that that actually can also be a very positive force. And a similar element, I think, is data. We live in a time of unprecedented growth in data. A lot of it in sectors that are absolutely crucial to society. I think Europe can play an important role in sharing and unlocking those data, not only in the public sector, in industry, and actually in Europe itself. Then risk. Again, risk you can approach from two ends. There is upside risk and downside risk. And again, I think hard to know in advance where the risk will go. So we had an interesting discussion how we can create a mentality, a culture, particularly young people, that all are born, with a lot of appetite for risk, and to kind of keep that engine going, and make an environment where you feel secure enough to take risk. And one environment where this happens is in research, in basic research. It's by definition a high risk, high reward adventure, and we often see that the most impactful products of research are exactly the high-risk ones. It's kind of the long tail in the distribution. And I think a common message that came in our discussions, the incredible importance of strengthening fundamental research in Europe, and where the ERC, of course, plays an exemplary role. Turning to the public sector, I think then it's good to ask ourselves how we can even strengthen that long-term stable environment that's absolutely necessary for research, to take these kind of calculated risk also as an individual. And the good examples in the world that we can copy. Someone emphasized, for instance, in the US, the difference between the NIH, that of course now very much under attack, I would say, and Howard Hughes Medical Institute, which provide a more stable and protected environment. Also, Europe has an incredibly important role in bringing people together. So not only the ERC and Marie Curie programs, but the European labs play an incredibly important role in brain circulation and building the networks that are crucial for us. Turning to the private sector, I think for me an interesting insight was that if we want to leverage our efforts to have a larger R&D expenditure in the private industry, which I think we all agree Europe needs, that it's just a fact of life that it often is the larger companies with the larger margins that can actually afford to have these very intensive R&D efforts. I find it very interesting, just as a number, that the top 10 US tech companies, I think last year, spent 220 billion in research and development, just to set the scale. And we will talk about what it means actually to have real private-public partnership, where there is a certain give and take on both sides. And as was mentioned, there is not really lack of money, but the thing is, how can Europe capitalize that money, whether it's pension funds or others that actually kind of also invest in, I would say, the one area where you in some sense have the most reliable rate of return, which is research and innovation. And finally, I think politics and policy. A it was mentioned that there's a certain risk of politicizing science. Well, I think it's much better to scientize, so to say, politics. That is to set our policy to enable to maximize the power of science to solve our challenges, because I think that's in the end why we are counting on science. And that means that we also have to have serious conversations about governance, about the independence of the institutions, about the autonomy. That is absolutely important. Well, we come back at in discussion. We are having this discussion not at a random moment in time. It's we are in a setting where the next framework program is slowly taking shape, and often in Europe everything is crystallized, but there are periods where things are more fluid, and that's exactly the phase where we now have these discussions. And then I think finally, and Maria, you already mentioned it, the importance of our values for Europe to be inclusive, embrace diversity, also the kinds of diversity that are more difficult to see, like socio-economic, and to really make sure, and gender, and to make sure that we are a welcoming environment in many ways, also inviting and welcoming talent around the world. So these were some of the brief issues, and I want to call my distinguished panelists to the floor. I will introduce you one by one when I start asking questions. So in view of time, I would ask you, all five of you, to please sit down here.
I was supposed to be on the
Sorry. Yes, sorry. Oui.
So first of all, I really recommend your stamina, because you had you had a whole day of discussions, and then sometimes we are at a level where I like to say everything has been said, but not yet by everyone, and somehow now you have the challenge to bring the audience in this. I think what I found a very fruitful discussion, and let me start with you, François van Boxmeer. No, you sit here as chair of the EU Roundtable of Industries, but of course you have a long and distinguished career in various kind of industries, Heineken, and presently leading Vodafone. And so you have a kind of a unique, comprehensive view of the industrial landscape in Europe. And seeing businesses, I would say, new and more established, small and large. So I would like to begin the discussion by asking you to reflect on the role that research and innovation plays in your family, so to say.
The short answer, it is the beginning of it. I think Ben alluded to that. Industry was born on science and not the other way around. Already in the 19th century, even the 18th century, building on previous knowledge. And I think it's still valid today for big and small. And so for today, I think it's very important that we continue also to invest, as you said, in that fundamental research, the blue sky research, the moonshot projects, as you call them in your world. Because ultimately, when you look at our history, it's that has fueled the industry 20, 30 years from now. So I think it's important that as we speak about building the next budget, FP10 as it is called, it's important that we double down still on that fundamental research where industry is not funding it properly. There you need the public sector. Big industry that earns a lot does a bit. Big industry that doesn't earn a lot does less and less. And small industry cannot afford. So I think it's important, and there the public sector continue to concentrate its efforts. And then the second observation, it is you have already known science that needs to be scaled up into economic opportunities. And I think that there Europe can speed up. A lot of, when R&D turns money into discovery, and then the next step is how you go from discovery into money, and that's innovation. That scale up is often I'm not saying it's absent in Europe, but it's often done in the US because the capital markets are there, the mentalities are more open to it, risk-taking is higher, and you have an immense market. Now, we have a market too, a single market of more than 400 million people. We have to leverage that, and for that, the task on the short term, now for this Commission, it is to, in collaboration with industry and science, to complete that single market, tear away the barriers between our 27 countries to render the potential of the 27 countries together as one single market to allow companies to scale up. Big companies can do that. They have enough means to do it. But smaller companies, SMEs, which we have thousands and are innovating, as well as startups, they're stuck. And then they go to the US. So it's important to remove regulatory barriers in Europe. That's an important thing. And it's worthwhile a whole seminar, if you will. And building capital markets which are conducive to finance the scale-up and the startups.
Thank you so much. I want to turn to you, Susanne Beckers. You are the Principal AI Strategic Director at SAP. AI, of course, is everywhere. So you're in many ways, I think, in the eyes at least of many, representing here the future of a large part of it. I want you to say a few words about, because the European Commission has not been doing nothing. There's the AI Act. There is the proposal to build the AI factories. So what's your view on these European initiatives? And do you see kind of a, I would say, a special European flavor in which AI will be developed?
Really represents our European
We should have.
No, you need to. Sorry, like this.
Thank you. Okay, then let's start over again. The EU AI Act.
No, it's not working.
Why don't you take this one? Yeah. Yes.
Can you hear me?
No. No.
AI filtering, you're not supposed to hear me.
Yeah.
Good. Okay, so again, the EU AI Act, it underlines our European values, right? It gives industries in the EU also a unique selling point in terms of providing trustful, reliable AI, right? That is something where we stand out. However, coming back to the fragmentation as well, the EU AI Act can be implemented by the different states in a different way. That creates additional friction and cost for industries as well. Then you mentioned as well AI factories. There is the initiative of building these so-called AI gigafactories in Europe. And there, overall, it is a good approach to bring together clusters, right? So we don't have all our experts just randomly distributed over all the countries, but we have these clusters. However, if we look over to the US, not every state has its own cluster. If you want to go to the US for AI, you go to Silicon Valley. If we have a couple of gigafactories in Europe, which gigafactory are you going to? If you consider them as centers of gravity and you're in between, right? Then you're not pulled to anything because you're in the middle of that. So the wish there would be to have one European-wide center of gravity for AI, which means, yes, not every country can have the full expertise there, but I would wish for the trust and the benefit of all the countries from one big weight, heavy weight on AI in Europe.
It's kind of interesting that we see this theme, and Jean-François, you mentioned it too, that what I'm hearing is more Europe, so to say, because this theme of having European regulation set and then 27 incarnations that are all slightly different, that creates barriers. So is this something you see more generally in industry?
In terms of AI?
Yes.
We see it globally as well, right? So every country tries to win this AI race right now. We see a lot of different regulations. A lot of these regulations also lean on the EU AI Act with their local specific flavor. But this fragmentation is ongoing. And of course, in the sense of protecting your own market, every country is increasingly coming up with regulations.
Thank you, Luis Serrano. I want to turn to you. You're a very accomplished scientist. You're currently the director of the Center of Genomics Regulation in Barcelona. But you also launched quite a few startups, right? So you can really navigate this landscape. I want you to reflect on something which I think is also a terrific opportunity. I briefly mentioned in my summary, which is the amount of data that's what we're sitting on, but it's also particularly in the health area, but it's also incredibly siloed. And so what is necessary to unleash that data, and also what will it mean actually in terms of not only in terms of interesting science, but also in terms of impact on our society, if we're able to really make use of all that?
Yeah, thank you for the question. I think it's a very relevant one. I was mentioning at the discussion today, one of the biggest successes of artificial intelligence, I mentioned it, is AlphaFold. This program developed up to predict three-dimensional structure of proteins.
The one that earned the Nobel Prize.
Yeah.
Of course, the scientist earned the Nobel Prize.
Yeah.
In some sense, the algorithm played an important role too.
But I think regarding to this, and we will go into the data, also it's important to say that one of the biggest difference between the States and Europe is that in the States, many of these big things that have happened recently have happened because they have been financed by private companies. And we don't have these giants in Europe that can hire 50, 60 people working on protein structure to develop AlphaFold. It's something we should consider, no? The other thing is regarding data management is, and I think it's one of the biggest strengths in Europe, is that we have an amazing social security system, health system that covers everyone. And this means that we have records of almost all of us. We have gone to the hospital, someplace, somewhere there is data regarding us. Also, when we go to the pharmacy and we ask for a medicine, this is registered, etc. But this data is fragmented. Even one hospital has the data in a different format than the other hospital. Now, if we will manage to really put all this data in a standardized manner, of course protecting the privacy of the people, but allowing the scientists and the companies to access it, this will be huge for Europe, because you will have records, someone took this medicine for 5 years and now is having this kind of cancer or this type of disease. If you can really analyze this data with AI, plus, of course, human intelligence, I think this will be amazing for the pharma industry and for science. And what this requires is just, first, the will of the countries to share. First, that's always a problem. But more important, we need to provide resources to hospitals, to health systems, to convince them to change the data in a way that can be compared across Europe. And this could be, I mean, someone was talking about moonshot programs. This could be a nice moonshot program. How to convince all the hospitals and health systems to put the data in a way that can be understood by any machine across Europe.
And do you think that Europe has a special advantage here? Because you said, we are a continent that is, has good social safety net. Often our healthcare is publicly funded. We are pretty high trust in terms of. So you think that this will be an environment where, in the end, because it will also be the individual citizens, of course, that will have to agree to share those data. But do you feel we have a special advantage?
For me, I think there is a special advantage here, because I say in the States, the majority, I mean, at least a large part of it is private. It's more, and it will be more difficult to convince them. But here, if we convince the government and we convince the public that it will be good for them, I think we have a huge advantage in this respect compared with any other continent.
Well, but kind of quite natural bring us to our next panelist, Marcus Schindler. You are also very accomplished scientist, but you are also the executive vice president and chief science officer at Novo Nordisk, and part-time professor. So, clearly your company is doing extremely well. But I would love to have you also reflect on, I would say, why you're doing so well, because clearly there is some important role of basic research that led to that, and what were the kind of timelines involved, and how can you say something about how it feels to have this success and then looking backwards and see what did we do right to be in this position now?
Yeah, great collage of questions. And for those of you who don't know, Novo Nordisk is a globally operating and Danish-based company founded more than 100 years ago, actually, on the discovery of insulin, which was done by the University of Toronto. So an academic research institution. And then our organization was funded on the principle that we got the manufacturing rights. So, and I think that is actually the fundamental principle, I think, which is interesting for pharmaceutical companies. We make medicines. We don't have to do the basic research that is the underlying principle for this. We invest heavily actually in it because we still want to understand, of course, the diseases we are working in. We want to understand patient heterogeneity, and maybe we'll talk a little bit more about sort of data and so forth. But the fundamental principle is that there's excellent scientific discoveries out there, and sometimes we don't even know where those discoveries will lead us, but when the time is right, we might pivot to something from it being interesting to it becoming useful. And we're the part that can make it more useful and turn projects into products, into medicines, and into, at the end of the day, commercial successes. On that topic, though, over the last 100 years, I would also like to mention that actually one of our founding fathers had the foresight to turn our company into a foundation. So we are still majority owned by a foundation, so profits de facto go back to society, which is interesting because it's also a microcosm then of one thing that is really dear to me, that this is a symbiotic ecosystem. This is not just pharma feeding off basic research and then making profits, but it's actually how all of this also
You
comes
also
back.
have the flow of money back to discovery.
Exactly, right? And so it becomes actually a flow, and that I think is something we should capitalize on a larger scale also in Europe, how we build this symbiotic relationship. And the other molecule our commercial success is currently based on was also discovered, obviously, in an academic environment. And I think that is really important to acknowledge this, and then to say our role is well to turn it into medicine. Last but not least, maybe on this question, basic and academic science fosters talent. This is what we live off, because none of our scientists was trained in our organization. They all come from university or research institutions actually around the globe. So we rely on the system to produce outstanding good researchers, right? Who are driven, passionate, and purposeful. We rely also actually on a system of peer-reviewed publication, because it gives us an angle to say, is our science actually world-class, or are we just fooling ourselves? So I think all of this makes total sense if we bring it all together, and I think it's fundamentally true in Europe. And we should really utilize it and also talk about it more.
Yeah, it's a wonderful example. I must say, recently visited the new Niels Bohr Institute in Copenhagen, which as a theoretical physicist has a certain meaning to me. And of course, thanks to the wonderful generosity of your foundation, it's doing really well. And I think that's a good bridge to you, Jeremy O'Brien, who's you're currently the CEO of PsyQuant. You're in industry, quantum technology, but of course you have been also professor of physics, both in Stanford and Bristol, and launched several companies. So two. That counts. You launched more than one company, so I think probably we want to clone you. We want more of you, but I also want you to reflect not only on that jump, But also because you were telling us you have experience doing this on some sense on both sides of the Atlantic, right? So it's almost the equivalent of the double slit experiment in entrepreneurship. So can you reflect both on that jump and on the different environments and, so to say, the strengths and weaknesses of the two systems and what we can learn from each other, particularly what Europe can learn from your experience in the US?
Yes, I think a constellation of questions was the description, and I will apply the same. I recently sat in Niels Bohr's original desk that's preserved in Copenhagen, which was a rare pleasure.
Did you have a
privilege.
terrific idea while sitting behind the desk?
The only idea I had was to rush my colleague to also insist that she get a photo of herself in Niels Bohr's desk. But yeah, so I have spent some decades, in academia, but also in private company, and in Europe and the US and also Australia and sometime in Japan as well. And I think we spent a lot of time today talking about risk, and I think that's when I arrived into Silicon Valley 10 years ago. A lot of people were surprised that you would resign from a tenured professorship, and I was surprised that they were surprised because, surely the risk would be, having spent 20 years in a university environment, to uncover some foundational research. The risk would be to not try and do it, and that was my position. And I was talking with colleagues today about when I was a professor of physics and electrical engineering, I would provoke young people with taking risks, and usually I would provoke them with, I don't think you're going to be starving on the street anytime soon. So let's not talk about optimizing your academic career. Let's talk about, doing something profoundly challenging, transformative of your sub-discipline, if not discipline, if not the world. And so I hope I won't offend too many people here, but I was surprised in academia at how risk averse it is as a place. I was so naive when I got my first faculty position. I thought, wow, this is fantastic. I'm unsackable basically, and I can really make some big bets now, and I can do anything and everything. And actually, I think there's a conservatism and risk aversion. A lot of the time, notwithstanding, extraordinary individuals who've done extraordinary things, but it takes extraordinary organizations like the European Research Council to support those things in an ongoing fashion.
You mean not only the risk of starting a company, but within research itself?
Yeah.
Within research, yeah.
Because some people say a lot of incentives are to do more of the same, right?
Right.
We need kind of maximum diversity, so to say, in our research effort.
Yeah, I think in research and starting a company and everywhere, I think a lot of it is about risk. I said to one of my teenage children the other day, there's not many things in life that are worth doing that are easy, and I think a corollary of that is that there's not many things that are worth doing full stop that don't have some risk associated with them. And if you're a university professor, never mind if you're a university student, you're a pretty privileged individual on this planet, and you can afford to take some risk. And indeed, you should be thinking about it as taking risk to do something, profoundly impactful. I don't mean taking risk for your own career and your own livelihood, but, particularly as discussed here, if you're privileged enough to live in Europe, where there's a considerable safety net for you. That there's very little personal risk of a real magnitude to worry about, and of course, when you start a company, you're risking other people's money, and that's a very big responsibility, and one that I have taken very seriously. And I think you asked me to talk a little bit about the US and Europe.
Europe experience.
Yeah, and I don't think it's black and white. I mean, I spent some time with governments around the world. Many of whom were obsessing about how to recreate Silicon Valley, just as many universities are trying to recreate Stanford whatever it is. And I think that's the wrong thing to do. I think the right thing to do is, just as we do as individuals, figure out what you can uniquely do as Europe or as whichever university it is. And I think there's plenty of things that Europe can uniquely do, many of which will be taking some of the best lessons from Silicon Valley, from the US in general, from China, from all over the world, but leveraging, you know, the culture, the values, the diversity of culture, diversity of language, and so on, that Europe is privileged to, you know, pretty well uniquely enjoy. And but there is also, I believe, you know, we talked about, I think it was scientizing politics. I think there has to be some you know, I don't know if this is out of date, but I once heard the statistic that 80% of people in the Chinese government were scientists and engineers by training. Now, scientists and engineers think about, you know, what it is that they're trying to do, and then think about, you know, how to get there, what the risks associated are, work from, you know, top down, bottom up, backwards, etc. That there's a really important feature, I would say, to thinking about the world like that. And some of that, you know, is hard economics that we're up against at the moment. And I would say, you know, we have energy, semiconductor chip manufacturing, AI, and I'm adding quantum computing, not just because it's what my company does, but I think they're the fuel for the economy, and we have to make sure we have all of them in a sustainable way.
Well, thank you. Jean-François, I saw you nodding when Jeremy was saying, well, we should not just only look at the US and try to copy that, but we have to have, you know, we have our own kind of European policies. Now, I know you're representing all of industry, so you like them all equally well. But can you help us kind of, you know, if you think about the importance, you already said how important basic research is, but if you see the challenges of industry, and particularly European industry, what are the kind of bottlenecks that you see have to be addressed, and in order to be not only competitive, but doing well and afford all the wonderful things that we have here in Europe?
I was nodding because you had the right priorities of where the future lies. So that is what I was nodding at. Now, our industry is very diverse, and you know, it covers the whole range of industry that was born already in the 19th century, and this is the industry of tomorrow that we have to cater for and develop and put a lot of efforts in. That does not mean we have to abandon all the rest, because they have their place in the value chain. I think when you look forward, the bottlenecks are clearly, I think I said it in my introduction, the single market.
Yes.
In an uncertain trading world as we witness, we have a single market, which is largely not, it's an idea of a single market. So there is a huge untapped potential in creating a more homogeneous single market. That's the first lever of growth that is available for all of us, industry and the economy as a whole. The second thing for industry in particular, and that is something which has not directly to do with science, but we have the specific conundrum in Europe that our energy is much more expensive than the United States of America or in China. It's even now higher than the Japanese. The fact that we always had it, a more expensive energy because we don't have it, or we have so little, made that our industry has been specializing in being very productive in the usage of energy, which is good. Innovative.
Yes.
Yeah, and at the forefront of it, and it can still be at the forefront of that. But we also embarked on an energy transition, whilst in a period where the fossil fuel, you know, kind of took the elevator. The Americans benefit from industrial gas 5 times than us. Industrial electricity is 1/3 of the price. The gap is huge, and we lose today, as we speak, our energy-intensive industries, which are perhaps traditional, but are important building blocks in building a whole chain of industry, including the industry of the future. So we should certainly concentrate a lot on the energy transition. That is important. That is seminal. There is where research and innovation comes back in. You would dream that all these carbon emission, if we can capture it and we could transform that carbon in something useful, or something that is not harmful. Otherwise, other than storing it underground in our exhausted gas fields or something like that, which is a good way of doing it, but that needs fundamental research if we think about it. So there are a lot of unresolved issues for that energy transition. There are a lot of bottlenecks in the regulation and everything we talked about that can be solved tomorrow and the day after tomorrow. And that is currently addressed, I think, by the Commission. Everybody is aware, the agenda is well understood. That is something which needs to be underlined and which is positive. But the day after tomorrow, then I think that science needs to come back in and really zoom in on that energy transition, because a lot of time it's about AI and digitalization and the chip technology, and that's all important. But the energy transition is ultimately also a thing that we Europeans need to win. And it will need a lot of innovation, but also fundamental research.
Suzanne, you clearly you will be also, your sector is your main consumer of energy. We talked about making that sustainable, and there are probably smart solutions. I also want to address you, one thing we haven't been talking about is the concept of time, in the sense, how fast things are developing. And you are in a very rapidly developing field. I know when I was a cabinet minister, we tried to, in the Netherlands government, to have a panel discussion, with ministers about AI, and I noticed it took longer to synchronize the calendars than for OpenAI to develop a new generation of chatbots. And again, we have this discussion about setting the next framework program, which is very exciting, but then we will set again, for some time. How are we, what are the lessons from your rapidly moving sector that, it's very difficult to plan ahead even 1 or 2 years, I think, and so what are the demands, what are the lessons or something that we should learn?
Yeah, so let's start a little bit with the LLMs first, the large language models. What we see in the market there is that performance-wise, they are saturating, right? We have a lot of competitors globally competing for the best LLMs. So performance-wise, they will come to a level, all of them. And with that, they are only differentiating in terms of how fair they are, what kind of cultural background do they have. So that is kind of not so fast-moving environment anymore. But if we look into what is going on,
it will stabilize, and
it will stabilize, right?
And we have some kind of European AI with good values and everything.
Yeah, and then you can also plan your meetings again, because that won't change rapidly.
That's good to know.
Good, but planning ahead in this kind of uncertainty requires you to do 2 things, or at least 2 things. One is fundamental research again, right? To be prepared for the stuff that might come up in the future, so that you have the base. And secondly, developing and innovating iteratively. What we see in AI is if we have a fast time to market, we can, even if the solution is not perfect yet, right? We can test it, we get feedback. So a close iterative loop on improving AI and all the associated technologies is very important to be able to keep up with the fast pace.
Terrific. Louise, I want to go back to you, because you spoke very eloquently about the opportunities with health data, etc. But you're also a practitioner of creating startups. So, and I know you've been very supportive and encouraging also young researchers to take the risk, these kind of, I would say, calculated risk. And so what have you learned, and what can we do more at the European scale to have our young people, give them the confidence and point out to the opportunities?
I mean, it's an interesting question. First, I think something that is very important is, and again, it's not because ERC is organizing it, it's because it's true that having 5 years funding, 2 million euros, allow you to have the freedom,
the stable environment.
The stable environment, not to ask for 20 small grants that then you need to disperse your group in 20 different projects.
Yes.
But to focus on one. And then when you focus on one, you can develop technologies, knowledge, etc., in a more efficient way. So I think this is important to say. Then I think we need to educate the young guys, the pre-doc, the postdocs, that the only way in science is not just to do a pre-doc, a postdoc, becoming a PI 10 years later, okay, start your lab, do some research, another research, that there are many other ways that are exciting in science. We not only are innovation, we have science communication, we have science grant writing, there are many different ways, and young people should not be obsessed only with being PI, no? And then I think Europe has changed in terms of a startup. I mean, 15 years ago, when I was MBL, if you created a company with 1 million euros, you were just jumping around the street. Now it's very common in Europe to create a company and have 4-6 million seed funding. This we are doing very well now. Also now it's quite frequent to go into a Series A of 20-30 million. So I think this is again good. What happened now is that when you have a successful Series A, then the Americans come and buy you and take you to the States. And this is the problem. We need to go from Series A to Series B and go to the 200 million, etc. And then what I have seen, at least at CRG, when I started as director, people didn't think about technology transfer. And now, after 15 years, people realize that you can do excellent science, and if you have excellent technology transfer office, it's easier to move what you're doing in the lab into a company. And then many of the young people, at least in my lab, they are the CEOs or the the CSO of these companies, because they realized that it's exciting to jump. And in many universities and centers in Europe, young people are not doing it because there are no examples. We need to give them successful examples, and then this will happen.
And I think you also make the case that, you know, people do the valorization, etc. You know, they have to be also at the right level, right? I mean, these are the kind of skills that we should kind of recognize in the same way in which we recognize excellent research skills.
Yeah, this again, I mean, at least in Spain, in other countries they are doing better, but in Spain, the universities, the technology transfer office is 2-3 people with a salary of 50,000, 40,000 euros. This is not competitive. You want to attract people that know the business, that can phone to the pharma companies, that can talk with them, that can identify the exciting things. For example, I mean, many people don't realize, but the CRISPR technology for genome modification was discovered by a Spanish researcher in Valencia, working in bacteria. He never realized that this was exciting. There was no technology transfer office at the university. And luckily, Charpentier in France took it, and it was not taken by the Americans. But this is an example, of something that has revolutionized genome engineering. And because there was not good technology transfer office, it disappeared.
Marcus, if you look at this kind of, what we see, the need for, I would say, more diverse roles and career path, not only have these various kind of ways to be involved in research enterprise, but also perhaps switch within your own career. Not only go from A to B, but perhaps from B to A again or something. So what can we do, and perhaps what does your company do to facilitate this more natural exchange between these communities? Because I think the one thing I surprised in these discussions is something, whether we discuss it from the academic point of view, or the industrial point of view, we seem to very much be of the same mind.
Yeah, I think that's a great point, and we touched earlier on about risk, and I think sometimes maybe we're confusing risk with unknown. Right? Something might simply be unknown or uncertain, and then there's a way to step forward into this. And that can be scientific technology, but it can also be ways of working. It can be operating in a commercial setting, can be operating in the public sector or in a hospital. And I think often barriers for the freedom of movement, if I may say so, are the fear of the unknown. It's not a real risk, but you just don't know. And hence you don't feel well equipped to actually take those steps. And I think it would be fundamentally important that we actually, in particular for young scientists, we talk about trilingual people now who know science, so biologically, chemical science, who also understand, of course, AI and digital. They don't have to be expert coders, but they need to know which tool to use to solve their problem. And understanding actually what we call enterprise thinking, so a business mindset. So how can you turn actually an idea into a project, into a product? Not that you have to do it, but you need to be aware, and there are certain skills and sometimes even language you use around this. And I think to do this well, actually, the best thing is immersion. So you actually live and breathe that world where you're in. So I do think the Europe and even ERC could facilitate this by, for example, having grants that encourages, maybe even demands, that kind of movement between the various sectors, but also across sectors, because I think innovation happens at the intersection, right? Chemistry, material science, and so forth. And when we're leaving that a little bit too much to chance, and we're actually putting some money and initiatives into bringing together those players and building programs for the next generation of what we see scientific leaders in our organization who are, fundamentally trilingual. But of course, something like this should happen at a much larger scale than just an individual
It's a very
company.
good point, because of course Europe, we have a wonderful tradition of European instruments, allowing researchers and students to cross national borders, but you say you should also have disciplinary borders or the private-public border,
Exactly.
which is, and there are not the instruments at this moment that encourage that. Jeremy, I want to, now you're in the field, quantum, which is, I think something that often, I think rightly so, it's crystallizing, but Europe has a serious position. We have some really excellent research centers. So one question that also came up, to which extent do we have this, what we do in the discussion, do not call a moonshot, but a moonshot-like approach. So do we need somehow a coherent European strategy around this? And what is the importance of kind of scale in order to for Europe to really be competitive in this area, where I think, in some sense the world is still quite fluent, and it's not yet, we haven't yet missed the boat, I would say so. So what is kind of needed for Europe to get its act here together, so to say?
Yeah, so I'm not qualified to suggest what any policy
You are.
might be, but I do think coordination and coherence across the continent is absolutely key, and as you point out, it's extremely fertile ground. This is where the underpinning science was invented, and indeed this is where back to Niels Bohr and his cohort. But also the more recent quantum information science, quantum computing theory, a lot of the experimental physics that underpins it, and so on. And I think in our very first comment, it was mentioned that the translation is critical. To take what we the existing knowledge, the existing scientific output, and translate it. And having observed operations in various different regions around the world, it's always interesting to me to I've now watched the US up close on this one, which is people are announcing billion-dollar flagships, billion-dollar investments at nation states in Europe, around the world, and so on, and the US is doing nothing. But you're not betting on them ending up behind or missing out, right? And I think what they do very well there is move very fast when the time comes. And I've sort of been, I saw that up close, and we had a little bit of a discussion around DARPA there today. And I don't want to get into a debate about the value of that or not, but I do think that the expertise that they bring to bear on things, the speed with which they can move.
But one point that we did discuss, and perhaps you can say something about it, is that it's very difficult now to project where in 5 or 10 years the investment should be, etc. So what do we demand of the instruments or something? So some kind of flexibility, or the need to react fast is part,
I think the need to react fast. We've talked about infrastructure across the board today, and I think that having continental infrastructure is very key there. And then it's maybe countercultural, but I think you need to pick winners. You know, you can't have 27 centres of excellence as discussed here in anything. And indeed, I think it's in the context of a world where, you know, I sometimes joke to people, we used to have multiple car companies for all 27 member nations. Now, of course, you would never expect when a new technology to come that there'd be a national champion of everything. And furthermore, I think, you know, we sort of anticipate that there'll be, you know, 1, 2, 3 global centers for any new thing, and you're sort of betting on the US and China for 2 of them. I would think that the world is a superior world if Europe is one of them, whatever it is. And I think you're right. It's not too late, but it is urgent.
Yes.
That you know, if you believe my claim that quantum computing sits beside oil, semiconductors, and AI as the underpinnings of, I don't really think about it as the economy. Of course, we were driven by the Draghi report today, and rightly so. But this is about impact for life and quality of life for humans. And you know, I would contend that, you know, living without access to and knowledge of how to use quantum computing will soon be like living without access to energy at a reasonable price, sustainable energy, existing without access to, you know, computer chips that pervade everything. You know, our cars have dozens of chips in them these days.
I saw these numbers. I think the current number that 30% or something of the current industry is based on quantum. And I always like to say, well, 100% of reality is based on
100% agree with that.
quantum. So we have to summarize, but perhaps very briefly, and I put you on the spot, whether you can formulate a single sentence, single point. We are in a position of building this next framework program. None of us are doing this actually, but you know, so this is your opportunity. Sorry. Oh, questions of the audience. Yes, so that's a good idea. No, we can do it. Let's move to think about that, and now we have an opportunity. Yes, right, to ask some questions for the audience. Sorry about that.
There is a over there.
Yes, and there is a mic, I think. Yes. So I'll take a few, and then we'll answer them collectively.
So, hi everyone. Great presentation and panel discussion. So, yeah, my name is Pandelis, and I'm a research and innovation attaché working at the Cypriot PermRep, and I'm also a scientist. So, yeah, regarding a few definitions or things that were mentioned in the panel. So back then when I was doing my PhD, I remember that students who wanted to try to go into enterprise, they would go to the business school of their university and do some kind of courses where they would essentially try different business models for ideas that were circulating around the university. So I was wondering whether it's a startup, scale up, the whole thing is it's a matter of definition, because startup and it's still a project, a research project. So you have trial and error, like in regular old school research. So and I was wondering whether it's about definition and whether we should look at startups as essentially research projects where trial and error is allowed, and actually fund these projects so you decrease the high risk factor.
Great questions.
So,
yeah. So I'm summarizing the difference between startups and scale-ups.
Definition, and then in terms of innovation hubs, where it should be partnerships between
we only have a few minutes, so this would be another interesting workshop to answer all of them. But another question, perhaps. Yeah, Kurt.
Did you get his question?
Hello, my name is Kurt de Ketelaar, Secretary General of the League of European Research Universities. I would like to congratulate the ERC with this event. We have 5 representatives of industry saying how important fundamental research is for their activities, for the development of Europe, for competitiveness. How do we explain then that since the second Commission von der Leyen started, the 1st of December of last year, they have been producing hundreds and hundreds of pages of paper on competitiveness, And in none of those documents, the word fundamental research is even mentioned. How do we explain that? And perhaps more important, what can you as industry do about that? Because we as academia repeat that every day of the week, certainly annoying a lot of people here in town. But I think that at the end of the day, perhaps they will listen to you. So I certainly would very much like to see you also repeating the fantastic message that you gave here this afternoon for the policymakers just a few hundred meters away from here. Thank you.
Thank you. One more question. Perhaps in the back I see one more question, and then we'll go back to the panel.
Hanna-Lena Ivarsson from Korea Public Affairs Consultancy. I want to follow up with a comment that one of you said, then come the Americans and buy the companies. How do we ensure that the startups scale up and become new big European companies so we don't lose our investment in research?
Okay, thank you. Good question. So let me start with this and the first question, the difference between the domains of startups and scale-ups, and where in some sense, this is some kind of a very vulnerable period. Any of you want to reflect on this? Jeremy, you perhaps?
I guess the startup scale-up thing I think is just definitional, and there's probably nothing in it. At least my experience in the US is there's no such thing as a scale-up, and for me it's a privately held company, publicly held company, profitable company, yet to be profitable company are the sort of definitions that matter. But the point I think to this last question is how do you bridge the gap? And it's extremely challenging, and it depends on the technology, the business, and the industry. And we are in one where it's a very big, expensive, capital-intensive business. I'm a huge fan of ASML, the Dutch company that many people don't appreciate is at the absolute heart of semiconductor chip manufacturing. I think that's a mega European success story that we should try to emulate. And I just learned there's a book on the topic called Focus. Which I've ordered.
Any other reflections on what the European Union, what the Commission could do, what the framework program could do to prevent this kind of poaching of companies?
Not the poaching per se, but I think in our discussion round this afternoon, we also discussed about learning and educating more about venture capital, right? We see there are two-sided benefits in terms of venture capital is way bigger in the US. And the benefits then for Europe, learning about this and being more risk-friendly there would be on the one hand side that the investment and the investors in Europe would benefit, and then on the other hand side, it would help maybe the startups to become scale-ups and then proper large-scale companies.
Thank you. And then I want to turn to Kurt's question and perhaps also make this the closing round, because one common theme has been in all your answers, and you said very carefully and thoughtfully how important basic research is, research in general. And yet we have to continuously articulate this, and I would say we probably have to retell it, But of course, also history books, people keep on writing books about Napoleon because you have to retell the story for a new audience. So perhaps from all of you, now what is the current perspective that brings this into focus and creates the urgency that we need for Europe right now? And perhaps I can start with you, Jean-François.
And perhaps I can answer to your question. Science is the mother of industry, and industry should not forget about its mother. And there is a lot of talk in the next for the next budgetary round of Europe to double the kind of full package scope 1, 2, and 3. And there will be an interesting debate on, I suppose, on how to allocate the money and what should go to the fundamental research. I am not qualified to say how much, but intuitively you would say you have to continue to sustain the effort, because that is our long-term perspective, I think. And we have a fantastic base in Europe, so please, we should not be pessimistic. We need, for God's sake, for our children to be optimistic about it. We have a fantastic education system here in Europe. We can leverage that. And I think that the future will be bright. I cannot say another thing than ending up on an optimistic note, but I think that science is at the base of the industry, and that should continue to be, I would say, supported in many ways, not only by money, but also by attitude. It's also in our families. How I convinced my daughter to go into biochemical instead of, arts. Say something.
Thank you, Suzanne.
I think we talked about also to get research and industry closer together, and not just metaphorically, but also physically. There are some great research campuses where industry and research is meeting, where students and experts from industry are exchanging on projects, doing common scientific development. And that can help us, of course, in the future as well. And of course, I have to bring AI as well again. Looking into the AI life cycle, AI is not a product you ship and it's like perfect, right? It develops over time. Models get better with retraining. And that also gives opportunity for industry and research again, because once it's shipped, it's industrialized, but it can get better, and that basically goes then back into research, which is a super approach, I think, and brings us closer together.
Wonderful, thank you. Luis?
Well, first I must make a disclaimer. I have funded 6 companies, but I am an academic, so I'm the only one that doesn't work for industry. Now, once I said this, I will make an analysis which probably is wrong, but at least from my point of view, there is something on it. And is, for many years, we had the framework program. They were funding fundamental research collaborative projects in Europe. When ERC started, I always say, ERC is the best thing in Europe, but one of the problems of the success of ERC is that the Commission will say that all the bottom-up science will be ERC, and the framework will become implementation and translational research. And I think probably the reason is because it's true that for many years, fifth framework, fourth framework, somehow we deliver great science, but I think we didn't deliver value. Or perhaps the reason is because I mentioned it in the discussion. EU was funding projects for 5 years, and when the project was mature, there was not a continuity. It was discontinue, and then the group of people collaborating were dispersing, and it never translated into value. And somehow I think the Commission thinks now that we need to create value, and we are, say, for example, the health pillar is implementation, is clinical records in hospital. This is not research. And I think they don't realize that if we only implement, soon there will be nothing to implement because there will be no discoveries behind, no? And we need to find a balance, and I think the Commission needs to realize that there need to be some fundamental research, not only by ERC, but in the whole system of networks, etc. And at the same time, we need to have the tools to make this science become companies that we didn't have before.
Thank you. Marcus?
Yeah, I think a lot about innovation supply chain. So how can we actually, on a sustainable level, continue to innovate? That means we need to have a system actually of suppliers of ideas, early projects, people who then also take it over, manufacture, and it becomes all a circular environment. And then the interesting thought is obviously if parts of this supply chain come under pressure or become very volatile and or unpredictable, as we're seeing now, and we see that at multiple levels, then your supply chain comes under stress and duress. And I think Europe has a unique position actually to provide stability and a level of predictability, maybe not on individual scientific level, but actually as a system. And for me, and maybe you can call me romantic in here or naive, I think we all align on fundamental basic principles. They are values. We are seeking scientific truth without ideology.
Yeah.
And this, I think, makes us very, very unique in this world, and it's something that gives me actually confidence. If that stays true, then we should be in a really good place.
Yeah.
Thank you. Jeremy, final words.
Optimism.
That's good.
and action. And yeah, it's challenging and it's hard work, but I think challenging hard work is fun and exciting. And it's particularly fun and exciting when you know for sure at the outset that you have all the ingredients, as we do.
Well, thank you, Maria. I had the duty to end this discussion on a high note, and I think thanks to the wonderful contribution of the 5 panelists, we managed to do so. And so I want to thank you for your contributions. And then, Madam President, I hand the word back to you. So thank you very much for your contribution.
Thank you, Robert.
What more can I say after this word of optimism? But I've also reiterate what I've heard. We're doing it for the fun of it, and that's really important, and we have the people in Europe who want to do it, so let's enable it. And Kurt, thank you for your encouragement for the representative industry to do something. Actually, the workshop almost ended, or in the very last part of the session, the workshop came with that same conclusion. And the group of people here and the group of people in the workshop agreed that they would work together and do something. And we'll just have to come up with what. But we're open to discussions, and thank you. I want to thank Robert again, and I want to thank the staff of the ERC who helped put this together. And now I wish you all a good evening. I hope you're inspired, and I'm sure our colleagues here will be open for questions. So thank you all, and have a nice evening.